Welcome everyone. This is a view of NASA's Jet Propulsion Laboratory nestled in the foothills of the San Gabriel Mountains near Pasadena, California. While you're looking down from the skies at JPL today, JPLers will be looking to the skies to wave at Saturn and maybe doing some hula hooping too. Hello, I'm Gay Hill. People are gathering on the mall behind me for a rare opportunity. One of our spacecraft, NASA's Cassini, will be imaging Saturn and its rings today, and our planet will be included in that picture. It's not often a spacecraft turns its camera towards Earth to take a picture of home. This time we know about it ahead of time to give people a heads up, no pun intended, to organize something that allows the world to get involved. The Cassini team is inviting people to look up and wave at Saturn when the cameras are snapping a picture of Earth. So here's the imaging window. It will start at 2:27 Pacific Daylight Time, 5:27 Eastern, or 21:27 Universal Time. Now, once it begins, it'll take about 14 minutes to acquire the Earth portion of the image. And while that's happening, folks will be waving at Saturn. So go ahead, send us a picture of you waving at Saturn by using the hashtag #WaveAtSaturn when posting on Twitter, Facebook, Instagram, and Google+. It may be used in a special collage created by the Cassini team. And we're already getting pictures here, and one of them is from amateur astronomer David Tyler from Blackwell Heath, England. That's a picture that he took overnight. We also received this cartoon from Jim Hunt. This is his self-portrait of himself waving at Saturn. All right, let's begin. To fill you in on what's happening, we have Scott Edgington with us. He is the Deputy Project Scientist for Cassini. So Scott, tell folks what this wave at Saturn is all about.
Well, we're here to participate in a worldwide event in conjunction with the Cassini spacecraft to wave at Saturn. We're going to be behind the planet, and we're going to snap pictures of the Earth while we're behind the planet.
Now, Cassini is really doing some serious business, though. It's not just to get this image of Earth. Tell us why Cassini's up there.
Well, you have a video here we could illustrate. We're there to study Saturn, the atmosphere, the rings around Saturn. We're also there to study the magnetic field of Saturn, the magnetic bubble surrounding Saturn. We're there to study this interesting moon called Titan. It's a very Earth-like moon. We typically call it a frozen Earth. And then we're also there to study the other icy satellites, including Enceladus. Enceladus is interesting because it has geysers that is sending off all this water ice into the surrounding environment.
And how are we going to image this picture? It's going to be a mosaic. Can you walk us through what the spacecraft will be doing?
Yes. If you imagine this is Saturn, you are the sun shining on Saturn.
The sun.
And then you have the dark side of Saturn.
Okay.
Cassini will be flying behind Saturn into its shadow. And then you have a mosaic.
We can show the actual footprint of how this mosaic will be made. We can roll that now. There it is.
There it is. You could see each footprint being laid across Saturn and the ring system. So each one of those is a postage stamp image of Saturn and the rings.
And those will be woven together?
Yes, those will be woven together. Take some time to piece them all together. And they will be taken in color, too, so you're going to get a natural color image of Saturn.
So what can people expect, this image of Earth? Will they be able to see pictures of people waving up at Saturn?
Unfortunately not. Our camera is a 1 megapixel camera. It's the best 1 megapixel camera out there, by the way. And but with that, the distance from Saturn to Earth is about 1 billion kilometers. So the resolution is just going to be about 2 pixels, 1 or 2 pixels.
So when might we see that picture? When will it be out, that 1 pixel, 1 or 2 pixel picture?
Well, it takes about a day or two to get the data, all the data onto the ground. And once it's on the ground, it needs to be processed by our software to clean it up and take care of any instrument artifacts. And then that will be released to the public. So a few days.
few days.
Yeah.
And the picture of the entire Saturn and its rings will take several hours to bring in. And when will we see that?
That takes a longer time to stitch together. You have to align each of those footprints up just right to make sure that everything's aligned and not distorted. And then they'll make a color image of that. So that takes some time to align everything up.
So
Roughly 3 weeks.
Now, this is not the first time that we're getting an image of Earth from a spacecraft. Is that right?
Yes. Of course, we have all these Earth orbiting satellites that take pictures of Earth. But the first deep space imaging of Earth was done by Voyager 1 after the Neptune encounter in 1990. The second time was in 2006 with Cassini, where we did the same thing. We took a mosaic, and Earth was just right there, and we snapped a picture of the Earth. This is the first time that we have told people that we are taking their picture, so that makes it very special. And gives us the opportunity to wave and hula hoop.
That's right. Well, it will be a fun day, and we have a lot of people out there. We have people already tweeting their photos to us, and thank you very much. This is going to be great. All right, we are about 6 minutes past the hour, and as Scott mentioned, Cassini has been a very, very successful mission. It celebrates Sweet 16 this year, 16 years of operation. And here's a look at some of its highlights.
And liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
We have a Doppler signature with engine turn on.
The Cassini mission has been extended twice and will continue to operate at Saturn until September 2017. And it is about 9 minutes past the hour, and the time to begin the wave, once again, is 2:27 Pacific Time, 5:27 Eastern. Do not forget to send us your waves via social media. Use the hashtag #WaveAtSaturn, hashtag #WaveAtSaturn. And again, we have already gotten a couple of pics. First one here is from Johnson Space Center. Those are all their student interns for the summer, and they are standing by live in mission control. That's a photo they shot just a few moments ago, and there it is, hashtag #WaveAtSaturn. We also have a picture from Canada. They are also doing a bit of a wave party. And we have a picture coming to us from the Eddington Astronomical Society. You are going to hear more from them. They are having a wave party at a castle, an 800-year-old castle, and we'll be hearing from a member of theirs. So now let me introduce you to a scientist who will be working on this image. Joe Burns is a member of the Cassini imaging team. He joins us via Skype from Cornell University in Ithaca, New York. Hi, Joe.
Hi, how are you, Gay?
I'm just fine. So tell us a little bit about the special geometry of what we have to do to get this picture.
Yeah, as Scott mentioned, we've got to get into the shadow of Saturn, behind Saturn, and look back toward the sun. We can't look directly at the sun because it would damage our spacecraft. But right in that vicinity of the sun, within a couple of degrees, will be the Earth, and so we can see that, and we can also see the rings in a very special sort of light. Here's an image from 2006 where we did this once before, and you see it looks totally different than the Saturn that you see on approach, and that's because these particles are highlighted, very small particles are highlighted because they're in what's called forward scattered light, with the sun coming in over their shoulder, essentially. You see the same thing with cobwebs. If the sun is on the opposite side or your source of light is on the opposite side of a cobweb, it will be highlighted, whereas if it's seen in back reflected light, you don't barely see the thing, or dust. And I'll try and illustrate that in a case of my own hair. Look at this. I can bring this up onto put the sun behind me, and you'll see the hair illuminated just on the edge. And whereas if this were the sun, my face itself wouldn't be illuminated at all. So we get to see these very small particles and see quite a different view of the planet and its surroundings. If I could have that next slide.
So, Joe, what do scientists actually learn by seeing Saturn in this sort of backlit way then?
Well, we see quite different particles, and those particles are subject to radiation forces. They have very short lifetimes, so we can see whether or not we'll be seeing the same amount of material as we did 9 years ago. And that gives us an opportunity to see the way that the radiation forces push material around, try to see whether or not the particles are coming off little moons. You saw the jets coming out of Enceladus, and if we can go back to that image, down in the bottom, you're looking at the top in reflected light, in the bottom in this forward scattered light. The bottom arc that's out on the outside of this image is, in fact, material that's thrown in by the satellite Enceladus. And in this image, we also found 3 other little moons, debris coming off small satellites. Will they be the same this time? Will our theories prove out to be correct, or how will we have to improve them? That's the sort of questions we're trying to do.
That's what I wanted to ask you, Joe. So you've been there before. You've been there in 2006. Why do you want to go back this time?
Well, we think things will change. Again, these particles coming out of Enceladus change over the course of time. Will the ring be brighter or less bright? Will so you can see the material coming out of Enceladus there, the bright spot in the middle, forward scattered again. We expect the solar radiation pressure to push the rings around. And in the last image, the sun was on the southern hemisphere. Right now, it's coming it's in the northern hemisphere, so the rings should be pushed to the south, whereas they were pushed to the north. But in the past, they didn't do quite what we expected. So we've tried to develop further theories, and now is their chance to test them. And that's the way science works. We see unusual things, we try to explain them, and then come back with better data to see whether or not we've done it right. And we're really eager to see this data come back for sure.
What sort of particles are we looking for? How small? What sort of things will you see?
These particles tend to be, and again, remember the ones in the case of the Enceladus are they're shooting out of a geyser. They're water droplets. They tend to be about the size of dust or flour, a familiar thing, or smoke. You see that in fog, same sort of stuff. Very small particles, so they have very short lifetimes because they can be pushed around and they can also be eroded away.
All right. Well, Joe, thanks so much for taking time with us. You going outside?
Absolutely.
All right, you got a couple of minutes left.
All right.
All right, take care. Thanks for joining us. It will take 3 hours for Cassini to snap images of the entire Saturn system. For the tiny 1-pixel portrait of Earth, it will take the light from Earth 80 minutes to travel from here to Cassini's cameras. The one-way light time is 80 minutes because Saturn is 900 million miles away. How far is that? Well, here are a couple of comparisons to give you some perspective. How far is 900 million miles? 900 million miles is equivalent to nearly 16 billion football fields laid end to end. The moon is 240,000 miles away. 900 million miles is equivalent to 1,875 round trips to the moon. Saturn is nearly 10 times as far from Earth as the Earth is from the Sun. So how long does it take to travel 900 million miles? Well, a 747 jet cruises at 570 miles per hour. It would take a 747 jet 180 years to fly to Saturn. The fastest land animal, the cheetah, can go 70 miles per hour. It would take a cheetah 1,467 years to run to Saturn. An average human's walking speed is 4 miles per hour. It would take a human 25,667 years, 128 days, and 6 hours to walk to Saturn. All right, let's take a gauge again. It is 16 minutes past the hour. We are about 10.5 minutes out from our wave. And people are planning impromptu wave parties all over the place. And again, remember that hashtag Wave at Saturn, including some folks at Comic-Con in San Diego, California. We've got a picture to show you. There they are. And I have to say, 2 of those folks are JPLers. Whitney is the girl in the purple hair. She is part of our media relations group. And Kim Stedman, she's in the purple shirt next to Whitney, and she is a part of the Cassini group, but they're at Comic-Con today, and they are still waving at Saturn. We have another picture to show you. This was sent to us from the Science Center of Iowa, and they, too, will be ready to go ahead and wave at Saturn just, less than 10 minutes from now. One wave party is taking place right now at the 800-year-old castle. At 800, that's Enrico Piazza. He is part of the Cassini team, and he's getting them organized right now, but it could be an unruly crowd. And one more time, let's start this again. One wave party taking place right now is at an 800-year castle in Kendal, England. The Eddington Astronomical Society is holding that party. Stuart Atkinson is a part of that group, and he joins us now by telephone. Hi, Stu.
Hello there. How are you doing?
Oh, we're just fine. Now, what time is it there right now?
It is now 10:18 p.m.
All right.
And the sky's getting dark. Got a lovely lavender-hued sky here. Marmalade sunset coming up 9:30, and we have just seen Saturn through a telescope for the first time.
Fantastic. How many people are out there?
We've got about 100 people here.
All right. So
and it's just a fantastic sight. Saturn like a little star above the trees, above the ruined castle. Like it's an 800-year-old castle. Saturn shining above it like a little golden sequin. Very pretty.
We see some pictures that you sent us. So is that your crowd there? You have a good group.
We've got a very good group. Yeah, people from all over the South Lakes. We've got people from quite a long way have come to our event here. And they're seeing Saturn. Everyone's very, very pleased indeed. So.
And this is a very special spot. Tell us a little bit about it.
The castle is 800 years old. It was the actual family home of one of Henry VIII's wives, Catherine Parr, the last wife of Henry VIII, actually. So it's a place steeped in history. And Kendal itself was a birthplace of an astronomer called Arthur Eddington, who helped Einstein with his relativity theory. So we're a historic town, and we're joining in this wave of Saturn. So we've got old history and modern technology in the same place. So it's all working very well so far. So
are you able to get Saturn already in your telescopes?
Yes, we've got a lovely view of Saturn through about 10 telescopes here.
And can you
just very, very small in the little telescopes, of course. The bigger ones, we can see the rings very clearly.
Okay.
You can just see Titan to one side like a little star. It's a beautiful view.
So what does it look like?
We've got the classic Saturn in a small telescope, a little disc, the rings around it, little halo around the center. And for many people, it's their first view of Saturn, so they're just amazed by what they're seeing. Many kids are just wowing and woos. Oh, look at this, Mom, this is cool. And it's just a really good night. So they're excited about doing this wave then? Very excited, yes. People have been reading in the newspapers and on the internet, of course. Oh, and some didn't know we were doing it. We just wandered past and what are you people doing on this hill with these telescopes? But now they're here. They're ready to join with waving at Saturn in about 10 minutes or so. Okay. And tell me how you feel about all of this. You know, granted that the image of Earth is just going to be a pixel, but it's still special to you. It is, yeah, because you're seeing our home from a billion miles away. I don't know why you wouldn't want to be looking at this picture or be part of this picture. I mean, we're at this castle, fine, but anyone in their garden can do it, in a park they can do it, in a school field they can be part of this amazing experience. And it doesn't happen very often. We can all just stop, catch our breath, and be part of this amazing portrait of our home planet. I mean, why wouldn't you want to do it? I can't understand that.
Well, this is fantastic. So you'll be waving the same time we will. Here at JPL, the crowd is starting to get a little bigger behind me,
yeah.
and folks are excited. So thanks again for sending all your pictures, and send more.
We're going to send you a lot more very soon, yes.
Okay. All right. Thank you, Stuart.
Thank you. Bye.
All right. Bye-bye. So it's about 20 minutes past the hour right now. It's less than 7 minutes away from the wave, and as I mentioned, the crowd out here is definitely getting bigger. Don't forget, go ahead and post your photos with the hashtag #WaveAtSaturn on Twitter, Facebook, Instagram, and Google+. Now let's go out to our mall and join Jane Houston Jones. Jane is an outreach specialist with Cassini and an amateur astronomer herself, and she's also the host of JPL's video series, What's Up? Hey, Jane.
Hi there. Hi there.
So what's it like out there? You're getting a big crowd.
Yeah, I almost can't hear myself talk. There's so many people out here.
It's fantastic. So tell me, where are people going to be looking?
Most of the people here are going to be looking to their east, which I'll just point this way. It's kind of down the main drag of JPL. And right now, Saturn has just risen above the horizon. So even though we can't see it in the daytime, it's already above our horizon.
Well, you have a couple of images that you can show us. Oh, look at that crowd, definitely.
Yeah.
People must have gotten the memo, eh?
Right. So one of the pictures...
All right, so we have some shots to kind of get an idea of where to look. Saturn's not going to be way up high in the sky, and of course it is the daytime, so folks here won't be able to see. But can you describe where to look?
Yes, look almost due east. So wherever you are in the U.S., look kind of to your east or to your southeast if you're kind of on the East Coast, and very close to the horizon, maybe less than 15 degrees above the horizon, and that's where you should face and wave.
All right. Now, people would definitely want to see Saturn at night. It's probably, you know, one of the favorite planets to look at night. Where should they look again at that time? And there are little things that can help guide them.
Right. Almost in the same area, you'll be looking to your east, up about 30 or 40 or 50 degrees up, and you'll see a golden star. And the easy way to see it is that the moon is on one side and Venus is on the other side. So there'll be two good signposts to help people find.
All right, so this is an event by the Cassini team, and one of the things that's going to be a real treat is taking all these images that people are tweeting in and posting on Facebook.
Right.
What are you going to do with them?
We're going to make a collage. So everyone who sends in either a photo they take of the planet, or a photo they take of themselves, or photos that they take of their friends or whatever, their dogs, especially if it's a cute dog, and send those into our Facebook page or Twitter. And what you'll be able to do is eventually we'll put a little collage together of all those pictures in a Saturn view, and then you can download that.
What do you think about this, Jane? The fact that, okay, the way that Saturn isn't a part of science, but this is a way of engaging people with science. What do you think about that?
Oh, boy. I've been looking at Saturn through telescopes for 25 years, and now I get a chance to have the Cassini spacecraft take a picture of me looking at it. I think that's pretty awesome.
Are people getting pretty excited? I know you run the Twitter for Cassini. What do you see?
Well, right now we're trending with with the Wave at Saturn hashtag. So that means a lot of people are using Twitter and using that hashtag. So, and all the people out here are pretty excited.
Why do you think that's the case? That this is something that people really embrace? Oh, I hear Enrico. What was
I hear
the time?
2 minutes. So
We're 2 minutes.
Yep.
Okay.
yeah, I think we can wrap this up.
Okay, well, we'll keep going until the countdown.
Okay.
You know, while we can break away just for a second, I wanted to show another picture. We have some pictures from Bonn, Germany. I'm going to see. There you go. There's a group in Bonn, Germany. So it's sort of like these are like your sidewalk astronomer sort of get-togethers, and they're getting together to look at the night sky, but they're also waving at Saturn, it seems.
That's right. All over the world, all over the U.S., people are going to be out waving at Saturn, and just like Stuart is doing in England right now.
And, you know, nobody seems to mind that, you know, maybe we won't be able to be seen on that 1 pixel picture.
Nobody's going to mind because they can actually see Saturn at night in a few hours, and they can see it for the next few months, too.
All right. Well, give me an idea, Jane, of who's coming out here. These are all JPLers. They're the Cassini team. Who's here?
Everybody's waving.
Oh, all right. It's almost time.
Hundreds of people are waving.
Okay, we are 45 seconds out, so we're just going to watch.
You will have to wait for 15 minutes. 15 minutes is what it takes to spacecraft. 10, 9,
8, 7, 6, 5, 4, 3, 2, 1.
Sorry, I didn't mean to. Say hi, Cassini.
Hi, Cassini. Don't go anywhere, but you can come out there and take some pictures.
So we have quite a crowd out here. There's got to be several hundred. This is great.
Oh, one more time. Oh, one more time. One more time.
All right. We got always a JPLer, always fun-loving group. There you have it. That wraps things up for us here at JPL. Our thanks to Stuart Atkinson and the folks at the Eddington Astronomical Society in Kendal, England, Joe Burns at Cornell, Scott Edgington, and Jane Houston-Jones with the Cassini team. This was really fun. Please continue to send us your wave photos for the Cassini team's special collage. And if you want more information on what's happening with Cassini and any of the other JPL missions, look us up on Facebook at facebook.com/NASAJPL, or go to our homepage. It's www.jpl.nasa.gov. But before we go, we'd like to leave you with this montage of Earth images taken from space and the words of Carl Sagan, which inspired us all. Pictures like these are few and far between. They're not easy to take. Special care has to be taken to not blind the cameras while looking in the direction of the sun where Earth happens to be. But the challenge is not the only part of our appreciation. These images are special for their unique perspective of our world, whether it's a big blue marble or a pale blue dot. It is ours. Thanks for joining us, everyone.
Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The Earth is a very small stage in a vast cosmic arena.